Hi folks, so in this video what we're going to be doing is the 2015 section B question from the Leaving Cert DCG paper, higher level, and the question itself is based from the topic on perspective. Okay, I have a couple of notes written down here, but I'm just going to read through the question on my screen here. So it says here, the figure B3 shows the outline, plan and elevation of a greenhouse based on the graphic on the right. We can see obviously the greenhouse here, we've got a pictorial down here. And then we've got the elevation and plan view down here with the measurements. Draw the given plan and make a perspective drawing of the structure given the following. Okay, so they said a pictorial view of the structure is also shown. The spectator point S is 4.5 meters from corner A. The picture plane is touching corner A. The horizon line is 3.25 meters above the ground line. And then the door and the window are in their closed positions. So you can see here in the pictorial, the door and the window are open, but at the moment when we're drawing it, we're just going to leave them in their closed positions. And then it says, use auxiliary vanishing points where appropriate. Note, it is not necessary to include hidden detail. Part B and Part C we'll get onto obviously later on in the question. So that's the problem there. We're given various heights, and we're given a scale of 1:50. So I'm just going to talk about that scale there now. So on my sheet here, I'm going to zoom in a little bit more here so you can see it. Essentially, all these measurements here, you can see here kind of scribbled out there, but that's 35 degrees is the angle of the pitch of the roof. The height here is 2.25 meters, and then the sections here are 1.5, 1.5, 1.5, and going downwards 1.5, and then 4.5 meters in length going across. Now, essentially, all I want to do is I want to apply my scale to work out what these measurements will be on my sheet. And you can see I have them already written in here, 30, 30, 30, 45 for the height, 120 and 90 down here. How did I work that out? So if I just take one of these 1.5s, okay, I want to basically bring this 1.5 meters down to a millimeter, okay? So what is 1.5 meters in millimeters? It is 1,500 millimeters. And essentially what I want to do then is divide that by 50, which is my scale. 1,500 divided by 50, I cancel the zeros, 150 divided by 5 equals 30. If I just take it for this one, 2.25 meters for the height, 2,250 divided by 50, get rid of the 0, divide 5 into 225 will give you 45. Okay, and you can see there I worked it out for all the other ones, and then I even use it for this one, 3,250. That actually has a relation up here to my horizon line. Okay, and the spectator point, 4.5 meters, you can see works out to be 90. Okay, so that's the scale there. Right, so what it says is we have to draw the plan and we have to start completing our question. You can see already, I have already drawn my plan using the measurements here that were on my sheet. 90 millimeters for the length, 120 for the height, and I split it up then into 30, 30, 30, and then 45 going across here twice. And then the window there obviously just bisected this line here to get that line in there. Okay, so anytime we start a perspective question, we have to get the picture plane. So how are we going to do that? So from the spectator, what you want to do is you want to go to the furthest leftmost point of the object, as you can see. So from the spectator, we're going to connect a line like this, and then I'm also going to do the exact same going to the furthest right. What that's after setting up for us now is what's called our cone of vision. Okay, it essentially means that that is the furthest left of the object we can see, and that is the furthest right of the object we can see. But in the cone of vision, you need to get your line of sight. Basically, what we want to do is we want to bisect the angle within the cone of vision. So put your compass on the spectator point, and we're going to bisect our angle. Okay, at that point right in there is going to be my little guide. Just going to put it in a little dashed line like that. That dashed line there that I'm just after drawing in is my line of sight, okay? And this is really important here because your line of sight will determine your picture plane, which is passing through corner A. So what I want to do is set up my set square on my line of sight. Remember, it's not corner A now. That's where lots of people might make an error here. So set up your set square with the line that you've just created there by bisecting the angle. And I'm going to rotate it around to get a perpendicular angle. And that there now is my picture plane. So I'm going to set up my picture plane. And I usually just kind of write it out here. P, P. If you want to write in picture plane, that's absolutely fine as well. Okay, the next thing we're going to do in our setup for this question is, from the spectator, I have to look at the way the faces of the object are going. So if we just go back to our pictorial here, I've obviously got faces running in this direction, okay, and faces running in this direction. Then obviously I have a sloped roof, and we'll get onto that about the auxiliary vanishing points in a minute. But my faces are essentially running either left to right, horizontal, or vertical, up and down. So from the spectator, I'm going to go horizontally across to hit my picture plane, and also vertically up. Okay, that's generally a lot of the setup done there now, okay, but we have to still set up our ground line and our horizon line. Now, usually what I would do in class, okay, is what I actually get my students to do is I get them, I'm just going to move my visualizer here a little bit now. I'm going to take off my masking tape. I find this the easiest way. If you want to use an adjustable set square, or just want to continue on using sliding set squares, that's absolutely fine. But I find a little bit of effort here in just removing the masking tape and setting up your T-square so that the T-square is in line with the picture plane will save a lot of hassle. Okay, just going to move that there now. Right, now that I've the sheet moved, I'm going to line the page up so that my T-square is parallel with my picture plane. This is the bit you have to be happy with that now. Now that that's parallel, I'm going to use the same tape to retape down my sheet. One more up here. There we go. Okay, the next part of the question, I'm just going to move this down slightly here. Next part of this question, I have to set up my ground line and my horizon line. Now, your ground line can be set up anywhere at all, okay? But based on the drawing here, you can see my spectators there. I'm going to bring it down just so that it's roughly in the screen there. Okay, so about here. That's going to be my ground line. I'm going to go GL. And then my horizon line, which I worked out from my measurements here earlier, the horizon line is 3.25 meters, works out to be 65 millimeters. I'm going to set my horizon line 65 millimeters above my ground line. So 65. That's the only measurement that's really important there. Light line for my horizon line. And on my horizon line, I'm going to write HL. And then on the horizon line, we're going to locate our two vanishing points, which are going to come from these lines here, which are parallel to our faces. We're at this point here, hit the picture plane, drop it down, that'll be VP1. And we're at this point here, hit our picture plane, drop it down, that'll be VP2. So vanishing point 1 and vanishing point 2. Okay, that's a lot of the setup for the question done. Now we can actually go on to start drawing the actual problem. So, first things first, okay, I want to use any points that are on essentially a height line, okay, and we know that corner A is touching our picture plane, therefore any line that is on corner A or any edge can be treated as a true length, okay, and this height from here up to here, they've given us that over here, it's a height of 45, so when I project A down, I can measure up 45 and I can then draw in this face here and I can work out this back edge over there as well before we get onto the picture roof. So I'm going to treat it, just going to do a little sketch here, as in if it is in two sections. If you imagine here, we've got a little box. Okay, there's that little box, there's corner A, and essentially I'm going to draw in that section first. And then after I get the box drawn, I'm going to put on the roof, okay, which is the triangular section on top, and that's what we're going to do to start off this question. So from corner A, which is touching the picture plane, I'm going to project that down now from A straight down like this, and where it hits the ground down here is a point on the ground. I'm going to measure up 45 millimeters because that is the height of the edge for corner A. So there's the 45. Draw that in. There's the first edge there. Now, this face here is running back in this direction, okay, which in my plan view is going in this direction here. So because it's going in this direction, I have to vanish it over to VP2. So from here, vanish to VP2, vanish to VP2. This face is running in this direction, which means it's going to vanish over to VP1. After we get this done, it's simply a case, somewhere along those faces, is simply a case of determining where this back edge is here and this edge is here. How do I find those? I want the spectator's view of it. Okay, so the spectator's view of this back edge over here, okay, is this point here, and as the spectator looks at that back edge, it's where it hits the picture plane, which is right here. Where it hits the picture plane, I'm going to drop that down. Okay, so at that point right there, project it down. Likewise with this one, the back edge over here, it's the spectator's view of it when it hits the picture plane. Where it hits the picture plane, drop it down. Okay, I'm heavy in this, heavy in this. And we want to draw it. If we imagine, as they said a while ago, when the door and the window are in their closed positions. So at the moment, put that in a little bit heavier there, and we can start to see the structure taking shape. Now imagine if I was to finish off that box there, this point here, which would be up here, that point there is running back over here to this face. So that means this point here would project over to VP1. And this point here, which is run over here, is going in this direction, which would project over to VP2. And that would actually help me complete that box there, which you can see. Now, the next bit I want to focus on, before I start putting in all these lines and these details here, is working out the pitch of the roof. And what it says here in the question, it's going to zoom in here, use an auxiliary vanishing point where appropriate. So an auxiliary vanishing point is helpful on any surface where we have an inclined, okay, an inclination or a slope. In this case, our slope is going at 35 degrees, or alternatively, we could say it's going at 35 degrees here, like this, okay? So what we want to do is we want to actually find another vanishing point that is going to give us that slope. So how do we do that? So what we want to do is, first of all, identify the face where the slope is on, okay? So if I come here to my plan view, where is my slope? My slope is actually on this face here, okay? This face right here, because this point here and here are these 2 points, and I know they're coming up like this in here somewhere. And that's the topmost point there, where it's going to be hitting. So in a minute, I know I'm going to need that. So while I'm at it, I'm going to bring this point down to the spectator. I often just stop it at the picture plane there. And I'm going to need that point in a minute, okay? Because that's going to actually show me where this point is. But how do I get the auxiliary vanishing point? So what we have to do is we have to set up a 35-degree angle, okay, from our spectator. Okay, so I'm just going to grab the protractor now. So with the protractor, what we're going to do is, that face is running in this direction, so we're using this line here. Okay, very, very important. I'm just going to highlight that there. I actually won't highlight it just yet. I'll leave it a minute, actually, sorry. So we're using this line here, and we're going to put our the center of our protractor on the spectator. Okay, and I'm going to read the angle, which is 35 degrees. So making sure your zero is on the line, I'm going to read around to 35 degrees. There's the 35. Made that little mark there. Now from the spectator, I'm going to extend on through that. And what's very, very important here is from this line here, and where this point is hitting the picture plane, I now want to extend perpendicular to this line. So to do that, that's how I would do it. I have to move. I'll actually have to move this. Just thinking here now. Apologies. Yeah, this will work now. Just rotate my set square. There we go. I'll rotate my set square. rotate it again. Just with the visualizer, I have to do an extra step or two here. There we go. Now, very important, the line I've just drawn there is perpendicular to this line here on my measuring line, the angle I measured from. Okay, perpendicular, so just put a little perpendicular symbol in there. And if you remember the 35-degree angle which I created at the very, very start, which was this angle inside here, that angle there, well, where that line goes up and intersects with the perpendicular line, gives me a point. Now that height there, that's the one I'm actually going to just put in a little red marker. Okay, that height from there to there is the height from my auxiliary vanishing point. And what I'm going to write in simply there is in height for AVP. So what we do is we take that height now on our compass, that height right there, take that height on our compass from there to there. I come down to VP1 because it was on this face. If you remember, it was on this face, so I'm still using this side. And I'm going to mark it from VP1 upwards. And you can see where it's after cutting there. This will be called AVP. And sometimes, depending on how many you get, you might call it AVP1. Okay, if you get another one, it can be obviously AVP2 and so on. So, now that I've found my auxiliary vanishing point, I'm going to use that to help me get this part of the roof. So from this point, I know it slopes upwards, okay, and it's going in this direction, so I'm staying over here, okay, but I'm going to connect it to AVP1. Okay, and somewhere along there is going to be the pitch of the roof. How do I find the exact point? Well, where the point is up here. It's the spectator's view of it, so you bring it down to the picture plane, in line with the spectator where it hits the picture plane, drop that down, and you can see where it intersects right there. That is the top of my roof. Now I can connect it down to here, and I've got the first portion. So at this point, I'm going to heavy that in. I'm going to heavy in this one. Okay, now the back portion of the roof from here, it's a horizontal line, running across here. Okay, and even though this is the top line on the roof, okay, that is still a horizontal line. It's parallel with the ground. So that line there, because it's running in this direction, will vanish back to VP2. Somewhere along that then is the backmost point. How would I find that? I could bring it down to my spectator, okay, wherever his pitch plane drop down, or from here, that's also a point that is running up on a slope at the back. Connect this point up here to AVP1. That's another way. Multiple ways you can go about these problems. And there we go. And there is the structure. Now I'm going to start putting in all the detail of obviously all of these lines here. So I'm going to start getting those in. So anywhere I've got a point, I'm going to bring it down in line with the spectator. Stop it at the picture plane. And this is where personally I feel it saves a little bit of time having rotated the sheet. Okay. So now that I've brought all those down, this one here, down to there, next one, there, and then this one here, to there. Now every one of those is sloping upwards, so technically every one of those will go to AVP1. I'm doing these very lightly. I'll heavy them in. So there's that first part. Now, they obviously run downwards. Okay, and I've got this line here running across the middle of the roof. Imagine the window was closed and it's not open, so I need to put in that line there. So I brought this one down. Okay, it hits right here. And now drop that down. And it's hitting here. And at that point there, the line is running in this direction. So it's going to vanish to VP2. heavy in that little portion of it there. Okay, next little bit we have to get in now is the door. So just on the door, okay, we have to come back to our drawing here for a second. Need a couple of measurements here. So for the door, you can see it goes up to the pitch of the roof here and here. But what's the measurement going in? It's 30 millimeters and 30 millimeters and 30 millimeters. So I actually have to just put that on my drawing here. Okay, so measuring this way, you can see a distance, it is 90 millimeters already. I'm going to mark the 30 and the 30. So 0 as far as 30 and then as far as 60. So those two marks are identifying to me where the door is. So to find those from the spectator, I want to see where the door is. Spectator lined up with them, bring it to the picture plane. And this one, luckily enough, seems to be already there for me. And then where they hit the picture plane, project them straight down. Right here. And I made my own error there. There is the door in its closed position, as they say. And it's running in that direction. So from here to the VP1. And my accuracy is actually quite good. It's working out perfectly here. And there we have it. There is our structure, part A of the drawing completed. Okay, so it says there, part A, draw the given plan and make a perspective drawing of the structure given the following, and we've used all this information here and we've actually completed this. Now, part B, I'm going to zoom in here now. It's saying then for part B, the door is then hinged open, as shown in the pictorial view. So we can see here the door is now in its open position. Okay, until it is parallel to the picture plane. So I'm going to highlight that there. That's important. Until it is parallel to the picture plane. That's your little hint. Okay, on your perspective drawing, show the door in this position. Okay, so essentially we have to draw now the object when the door has been opened and it is parallel with the picture plane. So just using the information there, essentially this edge here is our hinge, okay, and this is the bit that it's swinging out from. So it's swinging out from the hinge here. So technically this point right here, that 30 millimeters that we measured in, that's our hinge. So first thing I'm going to do is I need to rotate the door from the hinge, so it's going to swing around. So put the compass there, pencil point here, and I'm going to rotate the door. Okay, and the door rotates somewhere along that arc there. Now, remember the information that we highlighted? The door is then hinged open as shown in the pictorial view until it is parallel to the picture plane. So, here's our picture plane. We essentially want to go parallel to that. So, with a sliding set squares here. Actually, I don't even need sliding set squares because my page was rotated. But if you obviously didn't rotate your page, you would have to do sliding set squares. So, from here, I'm now going to do a line going across like that. Just realize I need to extend my arc a little bit further. Okay, and essentially the door was closed here. It's after opening out, and now the door is in this position. That's our door from there to there. So what we want to do now is just sort of simply want to draw that now in our perspective. So new part of the door is this point out here. So from the spectator, project that down. It's the spectator's view of it where it hits the picture plane. Drop it out. And what's really helpful here then is essentially because it is parallel with the picture plane, it'll actually stay parallel with the ground line here as well. So from here, it's going to go straight out. And from this point, straight out, we're going to draw in our door. Just going to heavy that in. So my masking tape is getting in the way there. There we have it. There is the door in its open position, okay? And if you imagine then, obviously, if it was open, we could put in details. I don't think they're asking for it, but we could, okay? If the door was open, you might see inside the greenhouse. So from this point back here, let's say we had that. I don't think this is asked, but that would extend back there, and I might obviously have a line in there now, okay? From up here, Same concept. I'm going to heavy in that bit. Okay, and then I might have some of these edges. I might see this one. So from here, I'm going to bring this to VP1. Okay, and that point right there will connect up to here. So I'll just put that one in. Yeah, something like that. And then this line down there. Now, I don't think that was asked for any of that detail inside there. Okay, but that's just my viewing of it when the door is open. Okay, yeah, so I don't think that was necessarily asked for. Right, now what we're going to do is the last part of the problem. Okay, so part A done, part B done. Part C, on your perspective drawing, show the roof window. So the window now, when it has been opened through an angle of 70 degrees. Okay, so essentially here, what we're trying to do is we're trying to open up this window here through an angle of 70 degrees. Like that. Okay, and that obviously is going to be our 70-degree angle inside there. Now, if I just bring you up here to this guy, okay, the elevation, they're trying to make it sound harder than it actually is. Okay, so if we actually if we were to do a straight line just going across that point there, okay, and we were trying to use simple mathematical geometries that you might have learned in first year or second year, vertically opposite angles. If this angle down here is 35 degrees, what is this angle inside here? Well, that obviously is 35 degrees as well. Okay, now if we were to extend this line on, this part of the roof, and extend it on, okay, if we were to extend that on, what would that angle be up here? From there to there, that would also be 35 degrees. Okay, and essentially what they've asked us here in the question is, on your perspective drawing, show the roof window when it has been opened through an angle of 70 degrees, 35 and 35, there's our 70 degrees. Okay, so essentially, to actually draw this guy here, that line there just continues on. Okay, that edge of the roof just continues on there to be able to do it. And what you'll actually find then is, if I was to actually draw that, let's say this was the roof, this point here will be directly below this point. Sorry, this point here will be directly below this point, because as it swings in an arc, they will stay perfectly in line. Okay, so wherever that point is then, it will be directly below it. Right, so we're going to use some of that information to help us get this little roof portion, or sorry, the little window part here. Okay, so to do that, it's still on this space here. This is the bit that we're focusing on, this point and this point. So I'm going to need the two of them. Now, this one has been brought down, this one has been brought down. I'll obviously extend it down in a minute. And they're going to be essentially up above this one and up above that. So what am I going to do? I'm going to need my auxiliary vanishing points. So what I'm actually going to do is, on this guy over here, on the left-hand side, this time, my auxiliary vanishing point, if you remember from this one, over here, my vanishing points were going upwards. Now, technically, because the roof went up here, and then when it was at the top, it goes down again. So from here, it goes up to the pitch, and when it's at the top, it goes back down, okay? This is the bit when it went up, and from here, it goes down. So if I wanted to find another vanishing point down here, an auxiliary vanishing point, just to show you how I would find it, this line over here, make sure I'm accurate there, I could extend this down, okay, and that distance that is there, this distance here, will equate the same way. Imagine if I did, remember the 35 degrees we did here, if I did it this way and we had a line going that way, well, that line there would be the same distance out on the opposite side, because it would be 35 degrees as well. So it's very easy for me to take this distance again, and then from VP1, just mark it going downwards. Okay, and you can see down here now, I'm going to call this one AVP2. Okay, so that's the second one I have there. Now, another way I could have found that, we'll just see a true test of my accuracy here now. Not too far off, pretty close there. By extending this one down through it, you can see I was pretty close there, okay? Wouldn't worry too much about that, that's just a little accuracy point. But here's my second vanishing point. Now what I want to do from this second vanishing point is, I want to extend up through this point and this point here. there's that one from AVP2 through this one. Okay, and somewhere that has gone through this point and this point, I have to now find these two here. So the first one was already brought down. Where that comes down, it's going to hit there. That is that one. And if I wanted to find the other one, technically it would come down. It's probably going to hit same there. But that line there is a horizontal line. Okay, where the pitch of the roof is, I just showed you here, that's a horizontal line. So technically, that line there is going in this direction. From here, it would vanish over to BP2. You can see my accuracy is actually working out really well in this question because they worked out perfectly there. I'll connect this one into there. And there we have it. There is the roof window when it has been opened through an angle of 70 degrees and just using a little bit of maths and a formula there to help us. That is the higher level part of the question. But you can see when you just work your way through it, it's not that difficult. They're trying to confuse you. Okay? So there you have it, guys. That there is the 2015 question for the higher level section B based on the topic of perspective. If you go into the examinations marking scheme, I don't think they have any of that detail done inside there. I just put it in obviously just for my own kind of referencing once the door was in its opened position. Okay, but that's the question done there, guys, for the 2015 paper section B. Hope you found that helpful.